Alrighty, so now let's talk about solving systems of equations. Basically, you're just finding the point of intersection or points of intersection. So, back in Algebra 2, it was just where two lines meet. Now what we're talking about is where two different functions, not necessarily being lines, where do they meet? Where do they intersect? Now, how do we do this? Again, going back to Algebra 2, we can use substitution. We can use elimination. Now, if you really liked elimination, you'll remember we did this with matrices, okay? So if you really like that and liked using your calculator for matrices, you can totally do that as well here. And the third way is just to graph it and see where they intersect. All right, types of solutions. Let's review that. So you can have one or more points of intersection, but just double check that none of these are wholes from the original equation, okay? If you have none, this usually means you've got parallel lines, or it just means these two functions do not intersect, okay? Also, when you use substitution or elimination, you'll get something that's false, okay? It'll be like 3 equals -5, something that's false. Therefore, these two functions do not intersect. You can also have infinitely many solutions, which means they are the same function. And when you do the algebra through substitution or elimination, you're going to get something's true, like 2 equals 2 or x equals x in that aspect, okay? So now let's do a couple examples just to refresh your memory of how to do substitution, elimination, and the graphing. Okay, so first let's look at substitution. Now, the easiest way to do substitution is solve both equations for y and then set the equations equal to each other, okay? So let me show you what that looks like. So 3x minus 4y equals 4, and x minus y equals 13, okay? So we could go ahead and just solve both of these equations for y, set them equal to each other. But since this y has something in front of it, and that's going to leave us with 3/4, that's not going to be fun. So what I'm going to do is I'm going to solve this equation for x, because that way it'll keep our x positive. So we're going to add the y over. Okay, and now what we're going to do is set this equation, we're going to substitute it in for the x over here. Okay, so 3 times 13 plus y minus 4y equals 4. Okay, distribute. Okay, subtract that over and combine like terms. So y equals 35. Okay, then we'll go back here and plug that in. So x equals 48. So the point of intersection is 48, 35, okay? And then how to check that. Okay, so 3 times 48 minus 4 times 35. Should give us 4, awesome. And then we'll check it again. So 48 minus 35 should give us 13. All right, so we have our point of intersection. So let's look at elimination. Okay, this is where you're going to manipulate the lines or the functions so that when you add straight down, the x either gets eliminated or the y gets eliminated. All right, so 4x squared minus 27y cubed equals 35. And what I like to do with these is I like to stack them. When I use substitution, I like to have them separate and away from each other. But for elimination, I do like to stack because that way you can see if you add straight down if it's going to get eliminated or not. So 8x squared plus 54y cubed equals 74. Okay, so I know if we multiply this one by -2, we can add straight down and eliminate the x squared, but really I want to get rid of this cube, okay? So what can we multiply y cubed by to get 54 out of the 27. So that would be 2 as well. So we're going to multiply this one by 2. Okay, so we get 8x squared minus 54y cubed equals 70. And then just rewrite this as it is. Okay, and now what we're going to do is add straight down because this will cancel. So we get 16x squared equals 144. Divide both sides by 16. We get 9. And square root both sides. We get plus minus 3. Okay, now you'll notice we have 2 different solutions, right? Because we have a positive 3 and a negative 3. So the first thing we'll need to do is plug in the positive 3. Now, if you'll notice, if we put in the negative 3 here, it's still going to come out positive. So really, it doesn't matter that we have 2 solutions because it's going to come out the same anyway. All right, so 4 times 9, 36, minus 27y cubed equals 35. Subtract the 36 over. Divide both sides by the negative 27. And then we're going to cube root both sides. So again, that's cube root of 1 over the cube root of 27, which will be 1/3. Okay, so our solutions are positive 3 and 1/3 and negative 3 and 1/3. Okay, now let's double check this. Okay, so now I'm going to check with the second one, or with the negative 3 on this one. So I'm going to go second entry, and that's going to pull the whole equation in. And now what I'm going to do is go right here, delete the 3, but insert parentheses negative 3. Okay, now on your calculator, don't forget you have to do this because now the calculator understands you want it to square the negative 3, not negate 3 squared. Okay. Good, 35. All right, so now we'll check the second equation. So 8 times 3 squared plus 54 times 1/3 cubed, 74. Again, second entry. Go in, delete the 3, insert parenthesis negative 3, and enter. 74. All right, so those are our solutions. Okay, now what if they were looking at a graph? Okay, they gave you y equals x minus 1 over x plus 1 and x minus y equals negative 2. Okay, so the first thing, since we're going to be using our calculators, first thing we need to do is make this into something that we can actually plug into our calculator. Okay, so we'll subtract the x over and divide by negative. Okay, now we'll take our calculator. Okay, the first one is x minus 1 divided by x plus 1 and x plus 2. Okay. Again, remember, since my calculator is a little old, that's the vertical asymptote, okay? All right, so we notice these never intersect. Okay, so we have no solution, right? All right, what if these were our next two equations, okay? So we have y equals 3x minus 2 divided by x plus 1, and also y equals 1/2 x plus 1 squared minus 3, right? So we plug those into our calculator, and this is our graph, okay? So we have 1, 2, 3 areas of intersection, okay? And what we're going to do is just ask our calculator to calculate that for us. First, we need to tell it where to be in order to, because I want this intersection right here. So what you're going to do is hit trace and then get the cursor close to this intersection. So I just hit -3, therefore it's the closest here, okay? So now we will do math, intersection. So it says first curve, yes. Second curve, yes. Okay, our first intersection is that, and we're just going to round to the nearest tenth. So -4.8, comma 4.3. All right, go back over here. And again, we're going to have to trace. So let's do 0. Oh, that's really close. Okay, so now we'll do math. Yes, yes, yes. Okay. So -0.1, -2.6. Okay, for our last intersection. Okay, so this will be -2-ish. Oh, I mean +2. Okay, perfect. So now exit, more math, intersection, yes, yes, yes. Okay, +1.9 and 1.3. Awesome. So that's how you would find the points of intersection just using your calculator. All right, now we're going to do an example of them giving you two different functions, giving you the x of those solutions, and you have to find the k variable that they haven't given you. So y equals -x plus k, and y equals x squared minus x minus 6. And there are solutions at x equals plus and minus 1. Okay, now we have to find k. So the first thing we're going to do is find out what our y value is when we have a +1 and a -1. We could easily do this in our calculator, but so y equals 1 squared minus 1 minus 6. So -6. And -1 squared minus -1 minus 6. So it'd be 2, so -4. So now that we have our points, we're just going to plug those points into the equation with the k. So y equals, so -6 equals -1 plus k, and -4 equals -1 plus k. All right, so this would be -1 added over, we get -5. Okay, -4, so that'll be a +1, so subtracted over -5. All right, so at least we know -5 is our k, and that is it. So go ahead and just plug your solutions into the equation you know, take those points and plug it into this equation to find k. And that's it.